Well, friends, it's me again, Dr. Patterson. In this video, I'm going to go over how to use the Fauxduino, which there totally is a joke if you've ever played King's Quest VII. So the Fauxduino is a emulator of the physical XY tables that we have in lab. And all I've done is take all of that functionality and instead of sending serial port commands to the Arduino, I have it plot different shapes in a MATLAB figure. So over in MATLAB, this is all assuming you've installed MechaGod. One of the classes that was included with it was the Fauxduino class. And so if we just do a clear all up top, we don't have to worry about closing any ports or anything like that, resetting the instruments, nothing. We just want to clear out any figures that there are, probably clear out the command window as well, so CLC. And all we need to do to create the Fauxduino object is say, we'll call it the faux object, is call the Fauxduino command. And that's it. And that constructor creates the Fauxduino object, which is passed back to the faux object in this case. So if I were to run this now, it tells you created a new Fauxduino object and a figure will pop up. That is the XY table simulator. It chooses a different random position to move to every time you start it. So if I run this again, I get a slightly different random position. I believe I would need to double check, but I think it's always in the upper right-hand corner. It's just randomly placed in the upper right-hand corner. So what we have is the current state for the X step pin, the current state for the X direction pin, also for the Y step and Y direction. The black boxes are the current values, or is the button pressed or not, for the XA switch, the XB switch, the YA switch, and the YB switch, okay? So when this carriage moves all the way down and hits this YB switch, it will turn red. And when this entire axis moves over to the side and hits the XB switch, the XB switch will turn red. It will signify that it is actually being hit. And if you run into it repeatedly, it actually plays a sound that kind of sounds like what happens with the XY table in lab. So what we need to do before we actually start moving it around is we need to configure those buttons. So just like I talked about in lab, I wish I could put this up in the upper right-hand corner. I still got the circuit board. So just like in the lecture, I went over the buttons are actually pulled up or need to be pulled up to operate correctly. So what can we do? Well, for those 4 buttons, we've got XA, XB, YA, and YB. Let's just label them those. Let's say XA is equal to D10, XB is equal to D9, YA is equal to D3, and YB is equal to D2. All right, so we've got those 4 switches now declared as variables, or sorry, the pin numbers for them declared as variables. Now we need to actually put those into specific states. And so we need to say, hey, faux object, I want you to configure pin, and then pass it the pin. In this case, we'll say XA, and we need to tell it to be in pull-up. Right? And we need to do that for all 4 pins. So we'll just go ahead and do what everybody tells us not to and cut and paste and do XA, XB, YA, YB. And then we can run this again. Close that Fauxduino. And nothing's really changed, right? That's okay. No errors is good in this case. It shouldn't do anything, and I was wrong. It just went to the lower left-hand corner. But now we can actually move it. think if you try to move it without doing this, it'll throw an error at you. We can check that in a second. But let's now move one of the motors. Let's give myself a 2-second pause here because I need to pull the window in view. And then, or wait, let me see if I can set this up. All right, so I got another screen set up to just focus on the figure for MATLAB. So we've configured the pins and then we're pausing. Now we can actually start stepping the motor. And if I go back, let's see if this will work. I might need to click around a few times. We need to remember the step and direction pins for X and Y. And so 6 is, let me just go back, fix that. There we go. So let's get those written down. Let's say X step is equal to D6. X direction is equal to, really, I'm only going to show you one axis right now, D7. And so now we've got the switches set up here and the step and direction pins for, at least for the x-axis. So let's now, for say 20 steps, make the x-axis move. So we could say for I is equal to 1 to 20, and then n down here. And then in here, this is where we want to make sure that we have that low to high, that rising edge transition for the pins to be registered for a step to actually take place. So let's say, hey, faux object, write digital pin, and we'll tell the X step pin to move to 0, or set it to 0. And then we're going to do the same thing except set it to 1. So we get a guaranteed 20 times transition from 0 volts to 5 volts. So 20 rising edges, we should see 20 steps. So if we were to run that, we'll get a slightly different position. Oh. Need to use character versions. Oh, this was a while ago. This is when MATLAB didn't support string versions. I should have changed that. Yeah. Go with it. You tried to tell D6 set all the input pin modes prior to proceeding. I did. Interesting. We're at a pause. It's a case issue. Might need to make some modifications on my code for this one. If that's the case. So it just did it 20 times. Obviously it did it much faster than what I was intending. So let's put a pause. 0.1 seconds in there. Oh, yep, you can slowly see it moving. If we go a little further, let's say 50. Hopefully you guys can see that super slow movement. So I need to, I'm going to write this down because I need to change that. So this is kind of remnants of a couple things that used to be a certain way in MATLAB. One was you could only specify pin numbers in characters, which are the single quotes, instead of the double quotes, which in MATLAB specifies a string versus a character array. And then the Fauxduino object, it used to be lowercase pull-up, and now it's uppercase pull up. So I will fix those so either one will work. I will pause and write that note. Okay. So what I'm going to do now is I'm going to have that move. I'm going to have it keep moving until it hits the A switch over here. And I'm even going to reduce this delay a whole bunch. What we're going to do is do a while loop, and I'm going to watch the state of the A pin. So while a faux object, tell me what's going on, read digital pin for the XA pin. 1 second. Okay, so while that is equal to 1, which means, again, in the Fauxduino and also the XY table class, or physical XY table, when it's equal to 1, because we have those pins in pull-up mode, it's going to read 1 while the button is not pressed. So kind of inverted logic from what we've had previously. So it should go all the way to the side and keep stepping until it hits that XA switch. So let's watch that happen. Oh, you need to use character versions. Really? I gotta fix that. Hopefully you guys don't even see those errors. Should be fixed before then. Let's do it again. So you can see it's slowly moving over to the side. It would go a little bit faster if I took those delays out. And we wait. And once it does this, I'll show you what happens if you keep stepping into it. I'll pause for a second. Okay, it's almost there. So once it hits, all right, you get a message if you take a step into it and it all tries to go past the physical limit, which in this case, it likely occurred because it was less than a full step away from the switch before hitting it. So it steps into it. You see that switch turn red because it's all the way up against the physical. And if we tried to take another step, let's grab those two lines, we'd hear that same sound again. And if you keep stepping into it, if we did that a few times, you're going to hear that knocking sound each time. And that's as close of a sound as I could get in MATLAB for representing the same thing that happens with the physical one. So hopefully this shows you how to use the Fauxduino class. If you want more information about any of the commands, if you head to my website, there's a new button down here, again, drnjp.com. It's for the Fauxduino class. It's all of the functions that are implemented. There are quite a few. If you're sick of waiting around, there's one for enabling or disabling different visuals, and it effectively makes everything happen much faster. You can disable the plots and everything. You can generate block patterns to actually scan and try to get information. We'll do something a little bit different next week, but if you've got any questions about it, check out the documentation. Otherwise, send me a message. See you later.